In this video, we will gather some data for gas pressure versus temperature. My students, you will use this for your data, for your lab notes. And the goal of this investigation really is to see how these two variables relate to one another. We're going to purposely change the temperature of the gas in this Erlenmeyer flask, which is sealed tightly. We're going to purposely change it to different temperatures, and we want to see how that pressure responds. So the setup is I've got a sealed Erlenmeyer flask with a gas pressure sensor hooked up to it. We should be able to see the values on my screen. Not sure why that clicked off. There we have it again. So we're going to use this actually as our first data point. We're at room temperature. 22.4 degrees is the air temperature in here right now. And we're going to assume that the air inside the flask is at that same temperature. So this is data point number 1, 22.4 degrees Celsius of the air inside the flask right now. And the pressure in kilopascals is fluctuating between 99.8 and 99.9. Let's go with 99.8, knowing that there's going to be a little bit of error there in that data point. So the next thing that I want to do, I'm going to go from coldest to warmest. So I have a hot water bath going over here, a boiling water bath that we'll use in a moment. I'm going to turn that down just a bit. And I'm going to put this in an ice water bath. We'll measure the temperature of the ice water bath. Of course, we expect it to be pretty close to 0 degrees Celsius. And we can see that temperature has already dipped down quite low towards 0. And I'm going to put the flask in as well. Now, what should happen to the gas particles inside the flask as they cool is that they should move slower. We know that temperature is tied to kinetic energy of particles. And we can see that the pressure is dropping. So the kilopascals is dropping as the air pressure decreases inside. And again, that's because the gas particles are moving slower. So what I want to wait to do is kind of wait until these two readings kind of stop moving, come to some sort of equilibrium, and then we'll gather that as our data point. Pressure still dropping. Temperature's dropping for that matter too. Still changing a bit. We are making an assumption here that the air inside the flask comes to the same temperature as the ice water bath. That's probably not exactly true, but short of getting a temperature sensor inside the flask, which is difficult to do to maintain the seal, this is the best we can do. All right, so let's let that be our next data point. 0.2 degrees Celsius, and let's go with 0.1 degrees Celsius and 91.8 kilopascals. All right, so I bring that out of the ice water bath. We'll see the temperature go up here. The pressure is going to go up as well as it just warms in the air. If I put my hands on it, I can warm up the inside even quicker. We can see the kilopascal pressure now going up pretty quickly. The warmth of my hands is making the gas particles move faster. Kind of interesting. And I'll let that continue to warm up a little bit. Now here, I've got just cold tap water. So I let the tap water run. I'm not sure what temperature it's going to be, but we'll get the temperature sensor in there. Oops, let me get my screen back. There we go. So the temperature of the cool water bath is not a lot cooler than the temperature of the air that we started with. So hopefully that stays put at about 20.1 degrees Celsius. I'm going to go ahead and put the flask of air inside, and we'll see if things change much. It's actually warming up a little bit. We'll see if we can get those two values to level off as our third data point. We'll see if that holds. Pressure inside has come up slightly again. What we're trying to do is get the air inside the flask to be the same temperature as the water bath, which one of the key things about heat is that if you have two samples at different temperature, you leave them in contact long enough, they will come to the same temperature. Now, air is not a great conductor of heat. Glass is not a super great conductor of heat, but we're going to assume that our temperature reading of the water bath is the same as the air temperature inside. Still fluctuating a little bit. Let's go ahead and take, well, might want to change still. Gotta be patient. Let's go with 20.2 degrees Celsius, corresponding to 99.6 kilopascals. And again, it's fluctuating, so we might be off by 1/10, but we know there's always some error in measured data that we'll go ahead and live with. And then the next one is the hot water bath. I want to be careful with this one. I don't really want to have super cold glassware going into super hot glassware. So I do want to warm it up a little bit with my hands until it at least feels back to kind of room temperature, maybe a little higher. You can see my hands are enough to warm it up already. The gas pressure is up over 100 kilopascals. I will, as a side note, say today we have rainy weather today, and the air pressure was below 100 kilopascals to start. On an ordinary day, you're going to see closer to 101 kilopascals as your atmospheric pressure. All right, so this is feeling a little bit warmer anyway. Let's get the temperature of our boiling water bath next. Again, we would expect it to be around 100 degrees Celsius, since that is the boiling point of water. So the temperature's rising. It should get pretty close to 100 degrees Celsius. And I did turn it down a little bit. It's not a super vigorous boil. Still going up. So let's go ahead and put the flask inside. Again, I need to be careful here. The hot plate is obviously hot. I don't want to melt any of the plastic tubing or cords. The other thing that can happen in this investigation is if the pressure goes up too much, it can actually pop the stopper out. So I'm going to apply just a little bit of pressure there at the top. Carefully put this in the water bath. And we really see the pressure going up now. This data point is going to be important. It's going to give us a data point in temperature way over to the right from the other data points. Again, we want those to kind of come to an equilibrium where they're not rising or dropping. I just had a thought. It might be good to get just a hot tap water bath as well. So we'll get that also once we get a reading here. So it looks now the pressure's not going to get much higher. So let's record 97.9 degrees Celsius as our temperature. Oh, it did bump up right when I said it. And the temperature's gone up too. Be a little more patient. So let's go with 98.2 degrees Celsius, and it's bouncing around there. Let's call it 122.8 kilopascals. 122.8 kilopascals, 98.2 degrees Celsius. And again, once we take it out, it immediately starts to cool. Pressure starts dropping. The temperature probe is still in the boiling water, so it hasn't changed. But when I remove that, of course, the temperature will change there as well. So I'll tell you what I'll do. I will get the hot water bath data point myself off camera, and I will put that in the comments below. So if you want that fifth data point, you can find that there. Thanks for watching.